So I'm going to be talking today about simplifying your SBOM management with Bomctl. My name is Alan Shearin. I'm one of the maintainers on the Bomctl project, which I'll get into detail with in a little bit. Obligatory introduction slide here. Work at Lockheed Martin, and I try to be a good open source citizen. That's what I'm putting forward. Award-winning Ian is also here. Golden Egg Award winner as of this morning. So we also wanted to keep this talk at 10 minutes, so he will not be talking. We realized that he could talk about SBOMs for quite a bit more than 10 minutes. So if you have questions or are passionate about SBOMs in general, after the talk, I mean both of us, but Ian is definitely here to do that. So Bomctl is a new open source OpenSSF sandbox project. It is format-agnostic SBOM management intended to bridge the gap between generation and analysis. So Bomctl use cases. Maybe you have you're maintainer on a project and everyone's telling you an SBOM, okay, I generated it, now what? That's kind of the end of the road for some people, but also if you have a more complicated software environment or you have multiple components to your software, so you have some kind of modern software system, not just a hello world on Trivy, you're going to have multiple components, maybe multiple images, and it's going to need to be somewhere else, or you're going to get it from somewhere else, maybe in a different format, and you don't really want to care about those things or worry about how it's going to get from place to place, or you know, maybe your supplier gives it to you in CycloneDX, but you need an SPDX, and your customer needs it in CycloneDX again, or whatever. So you don't need to really worry about those things. So most modern, modern software platforms, it's a list, or it's a tree of components. So this is one example of a Helm chart. So that's going to have multiple images, multiple sets of application code. And what does that SBOM look like? Is it just one 3 GB file, or is it going to be maybe a top-level BOM where you can point at the different components and have full SBOMs for each of those broken out components? So as an example, the software or the SBOM vulnerability tracker dependency track, which I've been doing some work on, just the core code would be 3 repositories and 7 images. What does that SBOM look like? That's going to be, is it going to be one massive file, or is it going to be multiple individual files with a little bit more succinct and hopefully non-duplicated components? Also, in the situation of an application image, it's usually going to have a base image, which Docker.io or Docker Hub may also have a SBOM available. So you don't want to have to reinvent the wheel on that. You don't want to have to rescan it and regenerate that SBOM. You want to use what they have, because that's the authoritative source. So some of the objectives for Bomctl, as you can tell by the name, it is a CLI. We take a lot of inspiration from kubectl, kubectl, kubecontrol, whatever you say. It's supporting daily operations and using an automation for your CI/CD pipeline to get your SBOMs from where they need to be, from where they are to where they need to be in any format without having to worry about that. So Bomctl is built on top of Protobom. About this time last year in Seattle, Puerco, there he is, talked about Protobom. So we take his and other maintainers' wonderful work on Protobom to kind of facilitate the movement and the generation of SBOMs between formats, and we don't kind of takes that problem out of the equation. Again, we want to support complex systems because, yes, you can just generate an SBOM with Trivy and call it done and put it in your repo somewhere. But what does that look like when you are delivering a product to a customer and you're trying to be a good security advocate and providing them a complete SBOM, enriched even, with maybe an author or a supplier, something that you should be filling out. So some of the commands that are already existing right now on Bomctl kind of should be we try to make them pretty straightforward and easy to intuit what they do. I can go through some of the more notable ones. So fetch does exactly what you think it does. It grabs a SBOM from somewhere else and brings it into your local cache, which I'll get to in a little bit. But it also will follow links. So if there's an external reference in an SBOM that you pull in and it points to another SBOM, it'll go ahead and grab that one as well, because we probably will need that one eventually since it's part of that first SBOM. Import, you can take it from like a local file if you have it, or if you are scanning locally with Trivy, you can also import from there. So it'll actually just, you can pipe in from Trivy and it'll just import the SBOM that way. And once you get into really big, complicated SBOM systems, you're going to have a bunch of, UUIDs in your cache, database list, which we may have time at the end to show you, but it's easier to work with if you can name these things. So if it's a specific product or a specific image, maybe a specific tag, you can kind of give them aliases to make them easier to work with. And all the other commands still work if you give something an alias and use an alias in the command line to run operations. List, pretty self-explanatory. You can also merge things. So if you are enriching or augmenting with a static SBOM, you can use merge to add things like the author field or supplier field or different things, or license, things like that. Tags, so if you want to keep all your container images as a separate set, and then you can list, okay, I want to list all only the SBOMs that have the okay, cool, I'm taking too long. Only the ones that have certain tags. Anyway, so link this is how you would facilitate building that tree of bombs. So you could be able to go in and physically link either a component or a document to other SBOMs within your local cache. We have it working internally. We're still working on getting it to the point where if you maybe push it to a GitHub repository, a GitHub registry, or different places like that, it'll actually represent those links in GitHub. So if you were to turn around and fetch it from a different computer, it would still take however many SBOMs you pushed up. So we're still working on that. But export and push, I mentioned push. You can export to something like Sift. So if you have another tool that needs to read in the SBOM, it can do that. Push will also, you can push it to any Git-based platform or another HTTP or URL. Yeah. So this is a little bit about the underworkings of Bomctl and how it works. So we don't have to care about if it's CycloneDX or SPDX. It'll pull it in using Protobom and its awesome protocol buffers. It'll serialize into the system and then actually get stored into a SQLite database locally. That's where you would kind of manage and hold all your SBOMs and do your operations, and then you could reserialize in any format if you like. So if you want to do omit all of them, that's fine. Also, we have it set up where if you maybe say you signed your SBOM and you wanted to maintain the original format, if you export it without specifying a format and you hadn't made any changes to the SBOM, it'll output the original content. So that's kind of an effort to keep A, signatures, and B, if there's any content that you don't want to lose. Because this is the things that Protobom kind of manages are the places where CycloneDX and SPDX are mapped together. If you have questions about that, since I can't get too far into it, please come and ask me. Parko probably can explain it as well as this guy. But yeah. And we would love for you to get involved. We have a long roadmap that I wouldn't have had time to explain anyway, but we can talk to you about that. We have a community meeting every second Wednesday of the month. Talk to us on Slack, get involved in GitHub, send us a message, make an issue, whatever you want to do. Get involved. We'd love to see you and talk to you.
I was just wondering if you tested this on any really, really large SBOMs yet?
We've tested it obviously on a bunch of SBOMs, but I don't know the largest one. Do you know?
So I'll make the argument that we're trying to mitigate really large SBOMs, right? The goal is that you're representing subsystems or subcomponents, and each of those have their own SBOMs, and you build a tree structure around them with multiple documents. So ideally, you wouldn't necessarily have, like, say, the Windows 3 GB SBOM being ingested into this tool.